Introducing DynoDesign, the solar site planner and estimating software from DynoRacks. This tool will allow you to quickly and easily create a layout for your solar project, perform the balance calculations, and create a complete bill of materials that lists all the mounting system components that you'll need for your project. First, you'll want to enter the address or coordinates for your project. Then click on Start New Project to get started. Next, select the Line tool from the toolbar in the upper left to start tracing the roof outline. Holding the Control button on your keyboard will force the angle between roof vertices to be increments of 15 degrees. Holding the Shift button will snap the vertex to an existing vertex that you've already drawn as part of the outline. Notice that as the vertices are drawn, the length of the vertices and the angle between vertices appears in the blue text. As soon as the polyline is completed, a roof object is designated and the roof name Roof1 appears in the list of objects on the right-hand side of the screen, which can be renamed as needed. Once the roof is defined, it has several properties, the first of which is the azimuth, which represents the direction that the modules will be tilted toward. You can type in the azimuth value, and a white arrow indicates which way the modules will be facing. You can also use the Snap button to select any vertex you see on the roof to automatically be reflected on the azimuth value. We also have properties of slope, height, and setback. This type of ballasted system will only work on flat to very low slope roofs. You can also define a parapet height, which will result in shading to represent the effects of the parapet. You may also utilize the Line tool or the Circle tool to define obstructions on the roof. As these obstructions are defined, they'll be added to the right sidebar where they can be renamed, or you can adjust height and setback as needed. The DynoDesign software will automatically use the height and the latitude to draw shaded areas on the roof where you should avoid placing solar panels in order to keep them out of the shade of the obstructions. On the Project tab, we can define some generic information about the client, like their address and description for the project. Finally, on the System tab, we can specify the solar module we're using from the database of modules. Once this is done, use the green Generate Design button to produce the system layout. The annual production, system size, and module count will generate in the bottom left. The Eyeball tool shows or hides the modules, and the Line tool can be used to create pathways, drawn as rectangles for the project. This requires you to regenerate the design. You can also create access pathways by using the Select or Multi-Select tools, with the Delete button in order to clear out modules from the array. You'll notice that the system specs will update in real time using this method. Once you have the system design needed, use the Generate BOM button. To run the ballast specifications and generate a bill of materials, you'll need to enter values in the wind speed, snow load, and exposure categories. Then hit Next. You now have a bill of materials that shows all the parts that you'll need for your project. Some of these parts are optional, such as wire pocket and dyno feather. You can add these components by clicking the quantity arrows or typing in the quantities into the boxes. Generating a PDF will produce a structural report for the project. Here you'll find all the calculations to determine the number and location of ballast blocks needed for this specific project. The ballast diagram uses a color coding system where the outline color is used to indicate where 2-leg and 4-leg baskets are needed, while the fill color indicates the number of ballast blocks needed in those baskets. From here, you'll be able to review the rest of your dyno design for this particular project. This is where you can also request a quote to purchase the specified materials. You can fill in your contact information and a targeted installation time for your project, and the request will go directly to the DynoRacks team. You can utilize the Other Downloads drop-down menu to access more files, like a JPEG image of the project. Another file you can access is a CSV file that contains the 8760 data for the production yield estimate for every hour of the year. Thank you for reviewing the DynoDesign software in this tutorial to help streamline the creation of your project, its bill of material and ballast plans directly on the DynoRacks website. If you have any questions, please reach out to us at sales@dynoracks.com.